morning. Welcome to our lesson for today in Quarter 3, Module 1, Describing Motion. At the end of this video, you will be able to describe the motion of an object in terms of distance and displacement, speed and velocity, and acceleration. These are the learning objectives that you need to learn at the end of this video. So let's describe first motion. Many things around us are moving. Some move slowly like turtles and clouds, while others move more quickly like rockets and lights. Because motion is so common, it seems to be very simple. But in science, describing motion actually entails careful use of some definition. So what is motion? Let's define motion. So motion is the act or process of moving or a particular action or movement of an object brought about by force. Motion is exhibited by a change in position. The terms speed, velocity, and acceleration are used to describe motion. The motion of an object traveling on a straight path is called rectilinear motion. An object traveling on a curved path is called curvilinear motion. And that an object that travels on a certain angle is called angular motion. How else can motion be defined? What quantities are used to describe distance covered and the speed of a moving object taking any of the paths mentioned? We will find an answer as we go along in this video. When describing the motion of an object, you must first be able to tell where exactly it is positioned. To describe exact position, it entails two ideas. First, it describes how far the object is. Second, it describes its direction relative to the reference point. A reference point is a place or object used for comparison to determine something is in motion. An object is in motion if it changes its position relative to the reference point. The initial position serves as the reference point. Let's take a look on the illustration. The distance between the dog and the house, as well as the distance between the cyclist and the house, is both 5 meters. The displacement of a dog while moving along the straight line from its original position towards the house is 5 meters east, while the displacement of a cyclist while moving in a straight line from her original position towards the house is 5 meters west. Even though they both move through equal distances, their displacements are different because the dog moves to the east while the cyclist moves to the west. Let's try the sample problem. On his way to school, Mike traveled 100 meters north, 300 meters east, 100 meters north, and 100 meters east, and 100 meters north. To solve for total distance, we simply add the given distances we have. So So the total distances that we have is the 100 meters, 300 meters, 100 meters, 100 meters, and another 100 meters. So the total distance is equals to D1 plus D2 plus D3 and so on. The total distance is equal to 100 meter plus 300 meter plus 100 meter plus 100 meter and another 100 meter for a total of 700 meters. To solve for total displacement, let us look at the illustration. You may notice that the figure forms a right triangle. The displacement made is the hypotenuse, while the given value is the leg on the y-axis and the leg on the x-axis. If you can remember the Pythagorean theorem that tells us the relationship in every right triangle is equal to this: a squared plus b squared is equals to c squared. Thus, we can get the formula of c is equals to the square root of a squared plus b squared. So our formula for the displacement is equals to dx squared plus dy squared, or the displacement on the x-axis squared plus the displacement on the y-axis squared. Using the formula, we can now solve for the displacement. Formula for displacement that we have, which is the total displacement is equal to the square root of dx squared plus the square root of dy squared. The total displacement is equal to the square root of 100 meter plus 300 meter squared on the x-axis plus 100 meter plus 100 meter and 100 meter squared on the y-axis. So the total displacement on the x-axis is 400 meters squared and 300 meters squared on the y-axis. Let's get the total displacement by getting its square root. So 250 meters squared, its square root is 500 meters. So the total displacement my got is 500 meters. So Mike traveled the total distance of 700 meters and displaced a total of 500 meters on his way to school. People usually associated speed with a fast-moving object, such as high-speed car in racing, but speed is usually defined as speed is the rate at which distance is covered at a given time. The formula for speed is the distance traveled over the total time elapsed. We can express speed in terms of miles per hour, kilometers per hour, and meters per second. When direction is associated with speed, you will have a new quantity known as velocity. So we can define velocity as a speed in a given direction. Velocity of an object changes when the speed changes, the direction changes, or both the speed and direction change. The car driving along a highway from one town to another might have a constant speed, but the velocity change nevertheless. If you are moving along 25 meters per second and then you will come a bend in a road, the velocity changes because your direction changed. So the formula for velocity is equal to displacement over time. Note that there is an arrow on the velocity and displacement to indicate that they are a vector quantity. So let's have an example about speed. Rachel watches a thunderstorm from her window. She sees a flash of lightning and begins counting the seconds until she hears the clap of thunder 5 seconds later. Assume that the speed of sound in air is 340 meters per second and the light was seen instantaneously. How far away was the lightning bolt? So we have the given values of speed is equal to 340 meters per second and the time is 5 seconds. So we are looking for the distance. We can get the formula for distance by getting its original formula. To get the distance, we can derive the formula from speed, which is the speed is equal to distance over time. So distance is equal to speed times time. So distance is equal to 340 meters per second times 5 seconds. We can just cancel out the same unit, which is seconds. So the total distance is equal to 1,700 meters. So let's have another example about speed. A car at rest starts moving and attains a speed of 50 meters per second in 15 seconds. How far has the car traveled in 15 seconds? So we can have the given of initial speed is equal to 0, final speed of 50 meters per second, and the time is 15 seconds. So the missing is still the distance. So we can get the total distance by using the formula earlier. But on this time, we have this initial and final speed. We can just simply get the speed by just adding the initial plus final speed divided by 2 times its time. So 0 plus 50 meters per second divided by 2 times 15 seconds. So the total speed is equal to 25 meters per second, which is the sum of the initial plus final speed times 15 seconds. We can just simply cancel out the same unit, which is the seconds, so that we can have the unit for distance, which is meter. So 25 meters per second times 15 seconds is equal to 375 meters. Acceleration is usually associated with the change in speed. When something speeds up, it accelerates. They say it accelerates, but acceleration involves more than a change in speed. It is a change in velocity. So acceleration is the rate of change in velocity at a given time interval. Acceleration is equal to the change in velocity over time. The unit for acceleration is meter per second squared. Let's have an example. Michael is driving his car at 30 meters per second. When he sees a dog on the road ahead, he slams on the brakes and comes to a stop in 3 seconds. What was the acceleration of Michael's car? So let's look for a given, which is the velocity 30 meters per second and the final velocity of 0 meters per second and the time of 3 seconds. So let's look for the acceleration. So the formula for acceleration is velocity over time, or the change of velocity over time. So we can just simply subtract the final velocity on its initial velocity. So 0 meters per second minus 30 meters per second over 3 seconds. So the total acceleration in this problem is equal to negative 10 meters per second squared. We can see that there is a negative sign. Usually this is called deceleration or decelerate, since it has a negative value. Let's take a look at on the summary of our lesson. First, we have motion. Is the movement of an object whirls about by force. Next in line is the reference point is used for comparison to determine if something is in motion. Third, distance is the interval between two locations measured along the actual path connecting them. Displacement is the shortest path in a straight line between the initial position and final position. Speed refers to how fast an object moves. Velocity refers to how fast and in what direction an object moves. And lastly, acceleration is a change in velocity. I hope you learned something on this video. Thank you for watching again and bye for now.